Virtual Private Cloud (VPC) design is a core part of cloud networking and cloud systems design. Subscribe to the channel and like this video for more great cloud tips. A VPC is your own logically isolated slice of a provider's network. Azure calls the same thing a virtual network, or VNet. You choose its address range, carve it into subnets, and control every route in and out. You get network isolation. It lets you define subnets, route tables, security groups, and network access control lists. You get better security over inbound and outbound traffic and over service exposure. You also get hybrid and multi-cloud connectivity plus compliance readiness. Isolation here means your traffic never touches another tenant, even on shared hardware. Nothing reaches the internet unless you build a path for it. That default posture is why a compromised web server does not automatically reach your database. Network segmentation splits one network into zones. Those zones cannot freely talk to each other. Get the layout right on day one. Readdressing a live network later is painful and rarely clean. IP address planning is the decision you are least able to undo. A VPC is defined by a CIDR block. CIDR is classless interdomain routing, the notation used to write an address range. A range like 10.0.0.0/16 gives you roughly 65,000 addresses. Pick private ranges from RFC 1918. Allocate non-overlapping blocks per environment and per region. Overlapping ranges are the single most common reason two networks cannot be peered later. Managed services quietly consume addresses too, so leave headroom rather than sizing for today's instance count. Subnetting divides that block into smaller ranges, each pinned to one availability zone. What makes a subnet public? A public subnet has a route to the internet, and a private subnet does not. Load balancers and bastion hosts live in public subnets. Application servers and databases stay private. Availability zone alignment means duplicating every tier across at least two zones. Then one zone failure is survivable. Keep subnet sizes consistent across zones. Uneven ranges make autoscaling fail in the smallest one. A route table is the lookup that decides where a packet leaves your subnet. Azure calls its custom entries user-defined routes, or UDRs. Google Cloud calls them routes on the VPC network. An internet gateway gives a subnet two-way public reachability. That is what makes it a public subnet. Why add a NAT gateway? A NAT gateway lets private instances call out for patches and APIs while blocking anything inbound. NAT is billed per hour and per gigabyte processed, so route bulk traffic to storage through private endpoints instead. Two filters guard your workloads, and confusing them causes hours of debugging. Security groups, called network security groups on Azure, attach to instances and are stateful. What does stateful mean? Stateful means a reply to an allowed request is automatically permitted, so you only write inbound rules. Network access control lists sit at the subnet edge. They are stateless, and they evaluate rules in numbered order. Do the real work in security groups. Reference one group from another rather than hard-coding addresses. Keep network access control lists as a coarse backstop for blocking whole ranges. VPC peering, or VNet peering, links two networks with private routing and no shared gateway. Peering is not transitive, so 10 networks fully meshed means 45 separate links to manage. A transit gateway, or Azure Virtual WAN, replaces that mesh with hub and spoke topology through one central router. Multi-VPC architecture separates production, staging, and regulated workloads. Those networks cannot reach each other by accident. Shared VPC on Google Cloud goes the other way. It lets many projects consume subnets a central team owns. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. Hybrid connectivity joins your cloud network to on-premises infrastructure. A site-to-site VPN over a VPN gateway is quick to stand up. It rides the public internet encrypted. Dedicated circuits go further. They are sold as Direct Connect on AWS, Express Route on Azure, and Cloud Interconnect on Google Cloud. Those give consistent latency and cheaper egress at the cost of weeks of lead time. DNS resolution has to be solved alongside routing. Use private hosted zones and conditional forwarders so names resolve identically on both sides. Traffic to managed services should never leave your private network at all. Private Link on AWS and Azure and Private Service Connect on Google Cloud exposes service as an address inside your own subnet. Egress filtering controls what your workloads may reach outbound, usually through a firewall with domain allow lists. That is what stops a compromised container from streaming data to an unknown host. Microsegmentation pushes the same idea down to individual workloads. Zero trust networking assumes the network is already hostile. The old bastion host is giving way to identity brokered access, such as AWS Systems Manager Session Manager. Security improves most, since a tight network is a hard prerequisite for any real compliance story. Why does segmentation matter? Blast radius shrinks because a breach in one segment stops at a boundary you drew deliberately. Cost drops when private endpoints and dedicated circuits replace MAT and public egress charges. Operations get simpler. Consistent addressing lets one Terraform module build every environment identically. Complexity is the real risk, and most teams overbuild their networks. A single VPC with public and private subnets across two zones covers most applications. Hub and spoke, inspection firewalls, and multi-account landing zones earn their cost only at real organizational scale. Serverless and fully managed platforms may need no custom network at all, so do not build one out of habit. A VPC is your isolated network in the cloud, defined by a CIDR block and divided into public and private subnets across availability zones. Route tables, gateways, security groups, and network access control lists decide what moves where. Peering, transit gateway, VPN, and dedicated circuits connect it outward. Plan addresses carefully, segment by trust level, and add complexity only when the organization actually demands it. Well, that does it for now. Hope you got something out of this video. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io. That's systemsarchitect.io and codeguides.io.